Okay, today we're going to be covering 4.7 radical equations. Last section we solved rational equations. There really wasn't many notes. We just got right into the solving. We're going to do the same here. We're just going to jump right into solving and doing examples. There's really nothing new that I can show you. Just work through some problems, show you some techniques. So the first example here, solve x equals the square root of x plus 7 plus 5. Whenever you have square roots involved in an equation you need to solve, you're going to want to try to isolate the term that has the square root in it. So we're going to try to isolate the square root of x plus 7. So first thing we're going to do is we're going to subtract 5. Once you've had that term that has a square root in it isolated, then we are going to get rid of the root. So in order to get rid of a square root, we will square both sides. But please remember that when you square a binomial, that means you actually are going to FOIL. Okay, that's x minus 5 twice. You are not allowed to distribute that exponent across a plus or minus sign. Okay, that is not allowed. On the right side, we're squaring a square root, so that cancels out the square root. We end up with x plus 7. Foiling out the left side, x squared minus 5x minus 5x plus 25 equals x plus 7. Clean up the left side. X squared minus 10x plus 25 equals x plus 7. And now we need to solve, so we're going to move everything over to the left side. We want the equation equal to 0 to see what we have. Looks like we're going to end up with a quadratic here. So x squared, we're going to subtract x and get negative 11x. And we're going to subtract 7 and get positive 18. Okay, so we have a quadratic. You have some choices here. You could factor it, complete the square, or quadratic formula. Looking at this looks like it does factor. So x minus 9 and x minus 2. So set each factor equal to 0. Solve for x. X equals 9. And x equals 2. Now here's the problem with getting rid of square roots or radicals. When you square something, there's a very good chance you're going to get extra answers, or sometimes it's called extraneous roots. You remember what roots are? That graphically means x-intercepts. Okay? So how do we check to see if our answers work? Well, two ways. One, we just plug back into the original problem. So we can plug 9 and 2 back in. Let's go back up to the original. If I plug 9 into the original, I have 9 equals the square root of 9 plus 7 plus 5. Or 9 equals the square root of 16 plus 5. Or 9 equals 4 plus 5. And that's true. 9 equals 9. That's good. 9 works. So we're going to keep 9. We're going to do the same thing with 2. Two equals the square root of 2 plus 7 plus 5. So 2 equals the square root of 9 plus 5. Or 2 equals 3 plus 5. Does 2 equal 8? The answer is no. Therefore, 2 does not work. That's one way of doing it. Plugging back in for your variable. Another way is to graphically look at it. So here we have graphing calculator. I'm going to graph this. Now when we do that, again, I like setting it equal to 0. So I'm going to move everything over. I'm going to subtract the square root of x plus 7, and I'm going to subtract 5, and I'm going to make y2 equal to 0. So we want the equation to be equal to 0 when you do this, because if it's equal to 0, that tells us that we're going to be looking for x-intercepts. Start with a zoom 6 and see what we get. Okay. Well, the only x-intercept I see is out here to the right, so I'm going to calculate that intersection. Put the x as close as you can to the x-intercept, and we get 9. What's happening at 2? Well, let's calculate the value at 2. Well, we're getting something else. Okay? So it doesn't work. The only x-intercept, the only solution to this problem is 9. So we can do it either graphically or we can do it by plugging back in. I actually think plugging back in is probably quicker and easier. But some people like to use the graphing calculator. Okay, so that's it. 9 is the solution to this example. Let's take a look at another example. Okay, solve 4 equals the cubed root of x plus 2 plus 8. We don't only, we can deal with any type of radical. Okay, square root's not the only thing that we're going to see. We could see cube roots. We could see any type of root. We could see the 12th root of something. Okay, again, we're going to isolate the variable or isolate the term that has the root in it. So we're going to isolate this. We have to subtract the 8 over. So negative 4 equals the cubed root of x plus 2. Now, in order to get rid of a square root, we squared both sides. So here, to get rid of a cubed root, we're going to cube both sides. Okay? If it was the 12th root, we would take both sides to the 12th power. Okay, that eliminates the radical. So on the left side, negative 4 cubed is negative 64. And the cube cancels out the cubed root. So all we have left is x plus 2. We subtract the 2, we get negative 66 equals x. Again, if we check our answer, we get 4 equals the cubed root of negative 66 plus 2. So 4 equals the cubed root of negative 64. The cubed root of negative 64 is negative 4. Negative 4 plus 8 is 4. This checks out. It's good. Negative 66 works. That was a heck of a lot easier than I thought it was going to be. That cubed root looks scary, but it's not. Okay, don't be afraid of it. Okay, on to the last example that we have for today. Solve the square root of x plus 10 equal to 5 minus the square root of 3 minus x. Okay, we have more than one radical. So isolating the radical is going to be somewhat difficult here. Okay, because there's not just one to isolate. Okay, there are 2 different types of radicals. If they were the same type of radical, we could move them over and combine them, but they're different. Radical x plus 10 is different from radical 3 minus x. So, in order to get rid of a square root, we have to square. So let's square what we have and see what happens. That's our only choice here. So we square this side, that's definitely going to eliminate the square root. The right side looks like we're going to have to FOIL out. That could be interesting. So square root goes away, x plus 10. The right side, let me write this out. You don't want anybody to think that you can distribute that too, because you're not allowed. You have to FOIL this side. So the x plus 10 is just going to hang out for a while. FOIL the right side. We get 25 outside. That's a minus 5 square root of 3 minus x. The inside, that's also minus 5 square root of 3 minus x. And your last is going to be positive. Okay, we have the square root of 3 minus x times the square root of 3 minus x. Well, a square root of something times the square root of that same thing will give you what is ever underneath the radical. So if I said the square root of 5 times the square root of 5, you would get 5. So the square root of 3 minus x times the square root of 3 minus x would give you 3 minus x. Okay, so let's clean this up. X plus 10 equals 25 minus 10 square root of 3 minus x plus 3 minus x. So x minus 10 equals 28. Let's put the minus x up front here. Minus 10 square root of 3 minus x. Okay, so we've combined all like terms. Now we have a single term here with a radical in it. So we can isolate that term. We'll subtract over the 28 and add the x. So if we add x, we'll have 2x. Subtract the 28. We end up, I wrote that wrong. We have x plus 10 here. Well, I wrote that as a minus. Okay, so rewrite that again. So x plus 10. All right, so we subtract the 28, we get negative 18. And we have this negative 10 times the square root of 3 minus x. We don't need to get rid of the negative 10. Okay, that's one term multiplied together. We can now square both sides to get rid of the square root. Okay, so the left side, again, we have to FOIL out. Negative 10 squared is 100. And the square root and the square cancels out, so we have 3 minus x left over. Okay, on the left side, we'll FOIL. We get 4x squared minus 36x minus 36x. And 18 squared, sorry, I don't know it off the top of my head. Actually, I think it's 324. It is, good. Okay, so plus 324. And we can go ahead and distribute the 100, so 300 minus 100x. Okay, we'll combine like terms on the left side first. So 36 is 72. And now we'll move everything over to the left so we can have it equal to 0, so we can solve. So if we add 100, we get positive 28x. We subtract 300, we get positive 24. Okay, good. We have a quadratic. We should try to simplify these numbers if we can. So we'll factor out a 4. Divide both sides by 4, and it goes away. And now, can we factor? Do we need to use completing the square or quadratic formula? This actually looks factorable. X plus 6 and x plus 1. Set each factor equal to 0. And solve for the variable. So we get negative 6 and negative 1. Again, we need to check our solutions. These might not work. They might both work. Okay? So negative 6 and negative 1 into the original. Okay, so if we put negative 6 in here, square root of negative 6 plus 10, is that equal to 5 minus, let's get rid of this squares here, 5 minus the square root of 3 minus a negative 6. Okay, so we get the square root of 4 on the left. Write it over here, square root of 4 On the right, we get 5 minus the square root of 9. So we get 2 equals 5 minus 3, 2 equals 2. That checks out. Negative 6 works. We're going to do the same thing with negative 1. We'll start over. Square root of negative 1 plus 10. 5 minus the square root of 3 minus negative 1. On the left, we get the square root of 9. On the right, we get the square root of 4. So square root of 9 is 3. 5 minus 2. 3 equals 3. That also checks out. So they both work. So both negative 6 and negative 1 work. And again, if you wanted to graphically check that, that's totally up to you. I don't think it's necessary, but if you wish to, you can. Again, make sure it's equal to 0 so you can check the x-intercepts. That's all that we have for today.